Example 2. Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. His goal is to earn at least $200 each week, but he can work a maximum of 20 hours per week. Malcolm must spend at least 5 hours per week walking his neighbor's dog. For how many hours should Malcolm work at each job in order to meet his goals? So the first thing that we need to do is identify our variables. And by doing that, we are going to create a system of equations. Now, why it says inequalities here is because if you look in the verbiage, we see these words at least, a maximum. So it looks like we can have more than one combination that could work, but we're trying to find what the optimal combination is. So we're going to be using inequalities rather than equal signs. And when we use equal signs, we're only looking for those intersecting points. So we're going to define our variables. So we have two different variables. The first one is our x value, which we're going to identify that as mowing lawns, and then our y value, which is walking dogs. Because ultimately, it says how many hours should Malcolm work at each job? So that's the question that we're trying to answer. That's how we determine that the x and the y variable are the mowing the lawn and the walking dog, the two different jobs. The next step we have to do is create our constraints. And by constraints, we mean inequalities. So let's come up with our inequalities. So we look at each sentence and then we create our equations. Malcolm wants to earn at least $200 each week at $20 per hour mowing lawns and $10 per hour walking dogs. So our equation shows the $200 isolated on one side. And the reason why the smaller end, so the closed mouth of the alligator, is pointing towards the 200 is because we want the other side to end up being more than $200 because he's asking for at least 200. And he is making $20 per hour that he mows the lawn and $10 per hour that he walks the dog. So that's our first constraint. Malcolm cannot work more than 20 hours. So the number of hours he works for mowing lawns plus the number of hours he works for walking the dogs has to be less than 20. And then the last sentence, Malcolm must spend at least 5 hours walking dogs each week. So that is a given that he has to do. So our walking the dogs, which is our y variable, has to be greater than or equal to 5. Then we're going to graph. In order to graph, we rearrange each equation so it's y, so the y is isolated. So with the first equation, when we rearrange it and simplify, we get 20 minus 2x. So our y-intercept is 20 and our slope is -2. We'll talk about the shading in a second. Then the next equation, which is the blue one, is y is less than or equal to 20 minus x. So our intercept is 20 at the y, and then -1 is our slope. And then we have our horizontal line at y is greater than 5. Look over at the actual graph, you can see the shading. So since we were shading above the red line, notice how the arrow goes to the right. Less than the blue line, the arrow goes to the left, and above the green line, the arrow goes up. So the yellow part here is all of the different possible combinations that satisfies the 3 inequalities. It says use arrows to show the region of the graph that satisfies each inequality. Shade the region. Any point in the shaded region, such as 12, 7, is a solution to the system. So if Malcolm spends 12 hours, because that's our x, mowing lawns and 7 hours walking dogs, he will have met his goal.